So if you open up Code Blocks, you're going to want to click on Create a New Project, and then click on Console Application. On mine it's in the top right corner of the window. On yours it may be different, but you want to click on Console Application and then hit Go. Then on the next window you want to hit Next until you get here. Make sure you highlight C++, click Next again, and then give your project a name. And mine, I'm just going to call it Tutorial 1, and then specify a folder to keep it in. Make sure it's a folder that you can find easily, and then click Next. Leave all the default settings on this window right here. These are simply directory and compiler settings. Just hit Finish, and then your project is created. So right now you don't see anything, but if you go over here to the left and click on Sources, you'll see the main.cpp file, which stands for main.c++. And if you double click it, you'll see the code. Now before we analyze this code, I want to go ahead and show you how to run it and what this code does. And to do that, on Windows you can either hit F9, or if you're on a Mac or Linux machine, you can just go up here and hit Build and Run. The code will compile, and then you'll see this console window. It prints the word Hello World, and it says process returned 0. Okay, so you can close out of this. Now that we know what the code does, we're going to look at how this code does what it does. So beginning with, kind of the main thing I want to show you in this tutorial, other than how to run your first program and compile it, is how to type out the skeleton of a C++ program. It's what I call the skeleton, and it's everything that you need for your code to run, at least in this course anyways, for every program that we will be writing together. So if we go ahead, I want to go ahead and take out this line, because this line is not actually needed for this program to compile and run. So if we take it out and we hit F9 and we build and run it again, we will get the process returned to 0. We just won't have Hello World printed to the console, which means, that's fine. The program just ran and executed till it finished with no errors, and it's a perfectly good program. So if we exit out of this, we're going to now analyze everything that we need, which is everything that you see right here. So starting from the top, you're going to see pound include IO stream. This line of code right here just simply tells the program that it needs to include a C++ library known as IO stream, which stands for input output stream. Now in every program that we write, you will need this line of code, which is why I include it in our skeleton. It's because if you don't have this line of code, your program will lose its basic input and output functionality. So you do need this line of code in every program that we write. Moving on, you're going to see using namespace standard. Now this line of code is not necessary for your program to run. Okay, so if we took this code out right now, it should still run fine. We hit F9, everything goes fine, and we still get the same result, process returned to 0. However, I do want this line of code in here for reasons that I'll explain in the future. For now, just know that we do want to include it as part of our skeleton, because it will make your life easier when we start writing more code, and I will show you why in future tutorials. But for now, just know that you do need using namespace standard semicolon. Okay, and it does end with a semicolon. Now, I know right now you're saying, why does this line of code end with a semicolon and this one doesn't? Well, we'll get to that in future tutorials. Again, it's all going to become a habit. For now, just know this is the code that you will need in all of our C++ programs. Moving on to the next big chunk of code. This right here is known as your main function. And in every C++ program that we write, you will need a main function. And to type it up, you just simply write int, which stands for integer, and then main, open parentheses, close parentheses, and then your brackets with the return 0 statement. Now in programming, there's two different conventions for writing these brackets. I want to go ahead and show them to you now so you don't get confused later if I do this. One convention is the way you just saw it, which is like this, where your brackets are open and closed down here. But the other way you may see it is like this, where your brackets open at the top and close down there, which is fine. There's no difference in the code whatsoever. It will run just the same. So just know that it's just a programming convention. There's no right or wrong way. Some people have their own opinions on why they do it a certain way, but just know, it's all a matter of preference. So before we end this tutorial, I want you to go through and I want you to type this up with me so you can get in the habit of doing it. So what's the first thing we need to do? Well, we need to include the input-output stream C++ library so that we can, output stuff to the console window. To do that, we're going to hit pound include IO stream. Okay, no semicolon on this line. Again, we'll get in the habit of knowing where to put them and where not to put them. But for now, just know there's no semicolon at the end of this line. Now, though we don't need it for this program, you do want it as part of your skeleton for this class. I do want you to get in the habit of writing it in all of our programs. So let's go ahead and do it now. You want to use the standard namespace. And how do we do that? Remember, we typed using namespace standard. And that one did have a semicolon. Moving on, the other really critical piece of code that we need for our program to run is the main function. And remember, that was preceded with int, which stood for integer, the name of the function, main, open parentheses, close parentheses, and then our brackets, depending on what convention you decide to use, will be different. And then return the value 0. This right here is working code. If you take out some of this code, such as that, this code will return an error. It will not run. So for now, just know that everything in this code is needed, and in future tutorials we will go into a discussion as to why they are needed and what exactly they do. Before we get into the code blocks editor, I kind of want to do this on a notepad sheet real quick so that we can show you. I want to kind of discuss with you how these data types are declared and what they mean. So a data type, what is a data type? What is a data type? A data type is basically a description of what we are using. So for instance, in the real world, if we were going to use the letter B, for instance, well, this is, to us, is known as a letter. This would be the data type in programming. Okay? Or what if we were talking about the number 7? Well, in our world, this is just called a number. This, again, is a data type. And, if we were talking about programming. Except in programming and in C++, we don't call them letters and numbers. So, what do we call them? Well, let's start with just a single letter. Let's just start with the character B. Okay, again, this is just a letter, but in programming, this is called a character data type. And the character data type, sorry about that, the character data type is denoted or kind of encapsulated with single quotation marks, as so. So that's how, so in C++, this letter B is called character data, and you have to declare it with single quotation marks. And when we get into example code, you'll understand what I mean by declare with single quotation marks. But let's move on to a number. So let's say 7. In C++, this is called an integer. And an integer is denoted just as it's seen. No quotation marks, nothing special. What about multiple letters though? What about, the name Bill? That's 4 characters, but this thing is a whole. What is it? Is that a word? In our world it's called a word, but what is it? What is it in C++? Well, in C++, it is known as a string, which is alphanumeric data. Okay, but for now, just know it's called a string data. And you denote string data with double quotation marks, as so. Okay? Now I kind of want to go over one last thing, and that's decimal numbers. So like 7.77. Is that an integer? Well, no, it's not, because it's not a whole number. So what is that called? Well, in this, it can be one of 2 things. Actually it can be multiple things, but for this course we're going to keep it simple. Know that it's either a float or a double. Okay? And it's denoted just as 7.77. For this class, we're going to use the word double, and the reason why is because if you use the word float, when you declare it as this, 7.77, behind the scenes in code blocks automatically converts it to a double anyways. So for now, we're just going to call it a double data type. Okay? So let's move on to some actual code, okay? And we're going to practice declaring these 4 major data types that I've shown you here. So let's open up our code. And by the way, in the last tutorial, the code was, I zoomed in if you couldn't tell, if it was hard for you to read in the last tutorial. Hopefully this will make it easier for you to read. So right now, let's go ahead and practice what we learned in the last tutorial in this project. I want to practice writing our skeleton, so to speak. Everything we need for our code to run. So we need to do basic input and output library. We need to include it. So let's include IO string. Okay. We want to use the standard namespace. Okay. And then we need to declare our main function. And we need a return value for this main function, which, as we said, we're going to use 0. And this is our skeleton. This is everything we learned in the last tutorial. Again, if you still haven't got this down yet, I suggest just practicing it over and over until you get it down to where you can basically write this code in your sleep to get your program to compile and run as so with process return 0. But let's get into our data types and variables. Okay, so we discussed what the data types were. It's kind of a description of what you're dealing with, but what's a variable? Well, a variable is kind of like a box, and your data type is a label on that box. That's how I want you to picture this. So you have a box, and then you have a label on this box. Okay, so let's say we put the letter B inside a box, okay? So the letter B is character data, right? We discussed this earlier. So, to declare the character data, we write CHAR, which stands for character, okay? So that's our label, character, CHAR, that we're putting on our box. Now our box is user-defined, meaning we can name it whatever we want. So I'm going to name it letter, because that's what's in this box, is letter. It's a letter, okay? And then we need to declare what the letter is, so we put a equal sign. I'm sorry about that, guys. I don't know what that is popping up. So you put an equal sign, okay? And then, again, character data is denoted with single quotation marks. And then inside the single quotation marks, we put our letter B. And then end the statement with a semicolon. And this right here is declaring a variable with the data type of character. And that variable, that character variable, is the letter B. Okay? So let's move on. Let's move on to the other. Now, if you don't know what this is used for yet, that's fine. In the next tutorial, we're going to discuss how we use these variables, what exactly they're used for. But for now, we're just declaring them, and I'm kind of giving you a visualization of what they are. Okay, so just for now, think of them as a box with a label and then something inside the box. In this case, it's a box that holds characters, and in the box is the character B. Okay? So let's move on to a number, a box that holds numbers. So again, a number is going to be an integer if it's a whole number. So to declare a whole number integer value, we write the word int, which you probably remember from here, int main, which we'll get into why you need that again in future tutorials. But for now, let's focus on this. And we're going to put a number in here, so let's call this variable number. Again, it's user defined. If I wanted to call it Jimmy, I could call it Jimmy. But you kind of want it, it's convention to call it something that it represents, so we're going to call it a number. And that's going to equal the number 7, and you end that with a semicolon. Remember, no quotation marks right here, just the number. Okay, so that's another variable. Let's do the other two variables again. Let's do let's make a variable that holds the name Bill inside. So to do that, we write string, because that's the data type. Remember, multiple letters is alphanumeric data is called string data. Okay, which I'll actually get into it later. String is technically a class. I know you don't know what class is, so for now just know it is a data type for now, okay? String data, and we're going to call it name equals double quotation marks Bill, semicolon. Okay, so there's your variable for a name, or multi-character data, okay? Now, in string, don't get it confused with only being characters. If I wanted to do Bill 99 hyphen semicolon inside these quotation marks, that's fine. Alphanumeric data will hold all these characters, and this will not cause an error. This is everything you can keep in this variable. That is fine. So just know that. But for now, actually, let's call it Bill 99, okay? So that you don't forget that you can actually put numbers in string. If you wanted to do just 99, you could, as long as you have the double quotation marks. It's still string data. Okay, but for now, it's Bill 99. And then for the last data type, let's do a decimal number, which remember I said it could be float or double, but for this class, we're going to use double. So it's double. Let's call it decimal equals 7.77 semicolon. And all this is fine. If we run this program, it will not cause any errors. Everything runs, process returns 0, same outcome. All this stuff is happening behind the scenes, so of course you won't see anything in the console window when we run it, anything different. You'll still get the same result, process returns 0, everything's fine. But the point is to just show you how to declare these variables and data types, kind of discuss what they are, and show that if you declare them right, you won't get an error. Let me show you what will happen if you if you call this character, or let's say we call it string, okay, without the double quotation marks. If you declare it wrong, which this is declared wrong because you're calling it a string and you don't have your double quotation marks. If you want it to be right, you'd have to put in double quotation marks. But if you take those out, then this is declared wrong, and when you try to build and run, you'll get an error. See this red box? And then if you look down here in the log, you can scroll down and it says error, conversion from double to non-scalar type standard : string requested. And that build failed, one error. So that right there will cause the program to crash. So we need to change that back to double. If we run it again, build and run, everything will go fine. So that's it for this tutorial. Let's move on to the next tutorial,